All right, so in the last couple of videos, we actually laid the foundation for this awesome world of regular expressions. In this video, we're actually going to double back on this topic and give these objects a formal definition. So as I've alluded to a few times in the last couple of videos, I've mentioned that these crazy little objects are actually going to be defined recursively. So what that means for us is that we're going to start off by defining some small little expressions that we're going to identify as being regular expressions. Then we're going to use these nice little operations that we just chatted about, and then we're going to essentially merge all of these things together to then give rise to this wonderful collection of things that we are going to call regular expressions. So the first ones are kind of silly, and we want to be kind of doubling back and thinking about the particular machine that's actually going to recognize this as being its language. So the very first thing is going to be the empty set. That is the set with no strings. So I'm going to claim that this is a regular expression. So right off the bat, you want to think about, is there one of these nice little machines that I can create that the language for that thing is then going to be nothing? That is, I want some little machine that doesn't recognize anything. It's going to reject every single possible word or string. So for this, it's actually pretty easy to draw. You're just going to make a nice little arrow in, and you're going to have a state. That state is not going to be a final state, and you can't leave with it on any random input at all. So no matter what, every single thing you shove into that machine is going to be rejected. So the language for that thing, so the language of whatever machine M, is then going to be empty. So you're not going to pick up anything. So the second thing that we're going to call a regular expression is going to then be this set that just contains the empty string. And that's different than what we see in part A. So what we're going to see in that one is going to be this nice little machine. It's going to come into an initial state, and it's not going to leave on anything, but if it stays put, it's then going to be accepted. So the only way that you can come into that thing and then not leave is if your input is just this empty string. So then the language for that particular machine is then going to be this set that only accepts the empty string. So notice that those two little machines are properly different. One of those is going to come in and have it not be a final state, and then the second one, it's actually coming in and it's going to be the final state. So they're subtle but very different. The third one then is really where this process starts to get some momentum. So this set that's then going to contain the string X is then going to be a regular expression. So if that set was, let's say this one, which is going to be this list of just the single character A, so this string of length 1, well, the machine for that we've seen a few times already. You're going to come in, you're going to have your initial state, you're going to leave that thing on a 0, and then you're maybe going to come into a final state. So we can start to see how the moment we have these lists that are then going to contain one string, we can then create lists that are going to contain 2 or 3 or 10,000 or a million or an infinite number of strings afterwards. And the way that we're going to begin combining things are then through these regular operations. So we know that concatenation is going to be an object we want to work with. We know the OR is going to be something we want to work with. And ultimately, we're going to want to take this star operation as well. So to kind of get us feeling through what this is all about, let's say we have these two little languages, A and B, both of which are going to contain a single string. This string is actually going to have length 1. And if you wanted to build the language AB, you could easily do that. That's through this concatenation. So what's going to happen there is that I'm going to have this nice little list that's going to have one word in it, which is the word 0, 1. Easy enough to do. You could then see that you could take AB and you could combine it with B through the OR operator, which would then create something like 0, 1 or a 1. And then from that, you could actually go ahead and do some concatenation again. So you could have A combined with AB or B. What's going to happen there is that this little 0 is going to be appended to the beginning of each of those little strings. So what's going to happen there is you're going to get a 0 from the A, 0, 1, and then you get like a 0, 1. So you can very quickly see how these little pieces are all going to begin combining into creating these more interesting languages. Things get really crazy, obviously, once you start taking the star operator, because, if you were to take A and then you union B, that's going to form this new little language of 0, 1. And if you take the star of that thing, so if you take A union B and you star it, well, that's the same thing as 0, 1 star, which we know actually is this collection of all possible words that are made out of zeros and ones. So it very quickly explodes into everything. So here you're going to see, that Empty string, you're going to have 0, you're going to have 1. You have what? 0, 0, 0, 1, 1, 0, 1, 1, so on and so forth. So you can see that you start this process off with tiny little nuggets of information. Let the recursion just kind of take hold, and all of a sudden you have this massive collection of all these nice little languages. So let's go ahead and actually practice a little bit more on different ways you can see the kind of combination take hold. Basically what this is alluding to is order does matter in the way that we view these things. Parentheses are going to matter, where we choose to take the stars, all of those random things afterwards. So what I'm giving you is I'm giving you the number 42. So we have 1, 0, 1, 0, 1, 0. And I'm simply asking you whether or not that particular word or string is going to live in these following languages. So the first one you can see is going to be a yeah, because we just said that this 0, 1 star is then the combination of all possible words made out of zeros and ones. You can have as many ones or as many zeros as you want. You actually can take none of them if you want to just use this empty string. But definitely this 1, 0, 1, 0, 1, 0 is going to live there. The other one's going to take a little bit more creativity to think through. So next up is going to be this 0, 1. So that concatenation of 0 and 1. And then I'm taking the star to that. So what that's going to tell me is that it's going to be any word that's going to be made out as many copies of 0 and 1 as you want. But the 0 and 1 are sandwiched together. So what that looks like is, well, you can take none of them, so the empty string. You could take 1 copy. You could take 2 copies. You could take 3 copies, and so on. What you're going to see is that 1, 0, 1, 0, 1, 0 is not in that combination. So that's going to be a no. The order's wrong. We needed the 1 first. So that's exactly what part C is all about. So what do we have here is then we're going to have all of these words that are going to contain any number of 1 zeros. So what we see then is going to be, well, we have the empty string, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and so on and so forth. And you can see right here is exactly where that number 42 happens to live. So that one's going to be a yes. And then if you look at the remaining 3, what's going to happen here is, well, if I look at 1 star, so I'm taking essentially, this B, I'm starring it, and then I'm going to take the A and then star it, and then I'm going to do concatenation. What that tells me is I'm going to have a whole bunch of 1s followed by a whole bunch of zeros. But I'm never going to get this alternating fashion to occur. So you're going to see things like 1, 1, 1, followed by as many zeros as you want to afterwards. Or maybe you have 1, 1, followed by a couple zeros. Maybe it's just zeros. Maybe it's just 1s. No matter what, you're always going to have this essentially kind of divider between the world of 1s and zeros. So the 1, 0, 1, 0, 1, 0 definitely is not going to live there. Things even get a little bit worse in part E. What that's going to tell me is that I have to start with a 1. And then after that, only is going to have a bunch of zeros. So something like 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, and so on. So definitely the number 42 is not there. And the same type of thing is going to happen down in part F. F is even worse because you have to start with a 0, which immediately throws our number out of the question because I need to have a 0 at my first slot, and, well, my object that I'm actually looking at doesn't have that thing. So that one's actually probably the easiest one to see that it's in fact unknown. So what's kind of underlying all of this is that you can easily build these things up to then create these massive languages. What's going to happen is that these massive languages are then always going to be connected to a machine. And you can kind of see how that's going to start up, is that once you can have these weirdo little, nice languages or these regular expressions, what's going to happen is that as long as I can do these 3 operations, I can always sew those things back together. And you very quickly see how this is all going to combine, is that you start with the little ones, you show how to do concatenation, you show how to do a union or an OR, you show how to do this star operator, and then all of a sudden the recursion takes hold, and voila, you have this massive arsenal of things to work with, and then you get to do a whole bunch of crazy things, and that's where things start to get really fun.